Okay, for this video, we're going to be continuing on with searching an array. Now, the only search we did prior to this in a video was a sequential search. We just went from the beginning of the array to the end of the array looking for the particular number or the particular element, right? But in the previous videos, we created the ability to sort an array, right? So if an array is sorted, we can do much faster searches. And one of the most common searches is a binary search. And let's talk about how this works, right? If an array is sorted, right? Which one was I using? Exchange sort. Let's just sort from least to greatest, right? Okay, so if an array is sorted and I'm looking for a number, I can always use a method that's going to always look at only half the array at once. So for instance, if I'm looking for the number 5, let's say I was looking for 5 right here. What I'm going to do is I'm going to take the middle number always in the array, right? And I'm going to look for it there, right? Since it's in order. So let's say the middle number was 22. So the number I'm looking for, 5, is less than 22. So what I'm going to do now is omit all this part of the array. So now my array that I need to search is just this bottom half because 5 is less than 22. Then I'm going to take the middle number of that array, which would be this one. And I'm going to say, is 5 less than 22? Yes, it is. So now I'm going to omit all this. All that's gone, right? And now I'm going to look in this part and I'm going to take the middle and say, is my number 5 less than 3? No, it's not, which means this is the number, right? So I'm going to continually go in half each time. So let's say I was searching for 55. I would have first started with the middle number 22 and said, wait, 55 is bigger than that. That means all these numbers aren't my number. So now I'm going to look for the middle number between these, right? And depending on whether you take the middle as less than or greater than integer would take this, I would find it right here. It's the middle number in the remaining array, right? So you're cutting the array in half all the time. So let's leave those sorts there and let's write a method that returns where it finds the element. And we'll say it's going to return a -1 if it doesn't find it, something like that, right? So let's call it binary search and we'll take an integer array, right? I'll call it array, right? And we take we can do this many ways, right? I'm going to take a lower bound and an upper bound to be able to call this array because I think it'll be easier for you to see. I don't need to do this. I can just use the lower bound and the upper bound in the code. Let's actually do that. Okay, so let's only take the key we're looking for, right? So there's my key. So this method is going to return, an integer where it finds the key or the number I'm looking for in array, right? So I need two key variables for this. I need a lower bound and an upper bound. And I'm going to start the lower bound at 0, right? And I'm going to start the upper bound at the end of the array, right? So upper bound is going to be, array.length. Okay, so the first time I'm checking, I need to search the whole array from 0 to the length of the array, right? So that's actually length -1, right? So if there's 5 elements in the array, then it's going to go from 0 to 4, right? Okay, so that defines my boundary, and I'm going to continually change that, right? And then I kind of need to know where, the position is that I'm actually going to look for the number, and I'll explain this in a second, right? Okay, so we're going to make the first number we look at, we're going to make it the lower bound plus the upper bound, right, divided by 2. So we're going to look at the middle number, right? Just like I was doing before. I was looking at the middle number, and then if my number was less, then I only looked at the bottom half. If my number was greater, then I looked at the top half, right? So the first number we're going to look at in the array is position, right? And we're going to go into a loop here while, the array position, right? While that one is not equal to the key that I'm looking for, right? And the lower bound is still less than or equal to the upper bound. Because once that swaps, then I know I didn't find my number, right? Because the lower bound would actually get higher than the upper bound. So that's kind of what my exit is, right? Upper bound. As long as those things are true, right, then we're going to go into our loop, right? So we check now, right? If the number that we looked at, which is array position, right? If it's greater than the key, what we're looking for, right? So then we want to decrease the position by 1. So we want to make the upper bound everything in the array up to but not including this spot, because we only want to look at the bottom half of the array, right? So if the number I was comparing it to was this one, we're going to omit all these by making the upper bound this 22, right? And the way we're going to do that is we're going to say upper bound equals position minus 1, right? And otherwise, that means that we now need to look at the top half of the array, and the way we're going to do that is we're going to change the lower bound, right? Equals the position plus 1. And the reason the minus 1 and plus 1, right, if I'm comparing it to this number, that number doesn't need to be in the array anymore because we know it's not that number, right? So if it's greater than, we're going to start with the 33 there. If it's less than, we're going to start with this 22, right? And after that, we now need to see the new position that we're going to search, right? So we need the new position we're going to search. So we'll say, right, you could put a blank line there if it helps you reading. We're going to say position is now the lower bound plus the upper bound, right, divided by 2, right? So now we have a new position. And I seem to have one right here. Okay. And now when I get out of this loop, right, this loop ends right there. When I get out of this loop, one of two things is going to be true, right? If the lower bound is less than or equal to upper bound, then I exited because I found it, right? So if the lower bound is less than or equal to the upper bound, then we actually found the number, right? And we're going to return that number back. We're going to return position back to the calling method. Else, we didn't find it, and we're going to return a -1, right? -1, right? Okay. And now the while loop is going to continue, right? It's going to continue. This loop is going to continue until one of two things happens. We find the key in the array, and it's going to drop out, or we exceeded it, meaning the lower bound actually became the upper bound, or even bigger than the upper bound because of integer division. But the lower bound actually became the upper bound, which means we ran out of array to search. One of those two things is going to exit. So if we exited because the lower bound actually became equal to it, right, then it's going to return a -1. And if the lower bound didn't become equal or larger, then we're going to actually return the position. So now I can call this method, right? We'll leave the sort in here. We no longer need to print the arrays out, right, after sorting, because we know it's sorted. And let's test the binary search, right? So we'll call binary search. We'll declare, a position where it is, and we'll call our binary search, and we'll pass it the array, which is numbers, right? And we'll pass it. Let's try to pass it a 5, for instance, right? A 5, right? So now let's see if it found a 5 in that array, right? So the position returned is, right, plus pos. Okay, and let's see what happens here when we run this code, right? So if I run the code, the position returned is 2. Now this is kind of deceiving because I'm looking at this array. Now in this case, it was position 2, but what's really happening is the search is working on the sorted array, right? So let's move our array printing, or the sort, up above it. So we're actually going to be looking at the array that it finds it in, right? So now let's look for, I don't know, a 212, right? 212 in the array. And we run it, and here's our sorted array, right? And 212 is the last one. So let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it did find it in the right position, right? If I was going to look for 5, right? If I look for 5, I should get the second position, right? So if I run this, it found the 5 in position 2. If I were going to look for a number like, 100, right? It should return a -1, which indicates that it didn't find that number. Position returned is -1. So again, binary search, key points to binary search. The array must be sorted before you use a binary search, because again, if I'm looking for a number in the array like 66, I'm going to first look at the middle number, and if 66 is bigger, I'm going to discard all those. So if it wasn't sorted, it wouldn't work, right? And then I'm only going to look at this, and then I'm going to take the middle number, right? And I'm going to find the 66 that way. So again, binary search requires the array to be sorted. However, once the array is sorted, searching is incredibly fast. Again, given the key you're looking for and the original array, it can be extremely faster than a sequential search, which is just going to blindly go through the array, and check each one. A sequential search would say, if I'm looking for 66, it would say, is 266? No. Is 366? No. Is 566? No. Is 2266? No. Is 22, right? And it would just continually go through. So a sequential search could be really efficient if you're looking for the first few numbers in the array, but again, we're using a very small array here, and the likelihood of finding your element in the first few searches is not great. So to use a binary search, we would use one of the more efficient sorts that we have at our disposal, and then we would use a binary search to find the number faster than a sequential search.